Hello everyone. So this is the question from Putnam 2024 contest, and the question says that Rn be the nth smallest positive solution to tan x is equal to x, where the argument of tangent is in radians. Simply the x value is in radian, and we have to prove that the expression Rn plus 1 minus Rn minus pi lies between 0 and 1 over n square plus n times pi, and it is for n greater than or equal to 1. So before watching the solution, I suggest you to take the pause and attempt this question. By the way, we solve this question by some graphical observation. We draw the graph of tan x and x on the same plot, because when they intersect on points, those points will give you the solution points. And we can see that where is the solution happening, and with some observations we establish our proof. So we have the graph and we try to observe. So we have, first of all, is given that tan x is equal to x. This is the equation we have. The Rn is the smallest solution and Rn plus 1 is the next solution. And the expression I have is Rn plus 1 minus Rn minus pi. This expression I have to prove that it is lying between 0 and this quantity. What is the meaning of this thing? Suppose I plug n is equal to 1 there in this expression. What I'm achieving? I'm getting this R2 minus R1 minus pi. Let's first understand what this expression means to us, or what this expression geometrically indicating something or not. So R2 minus R1 minus pi can be also written as, you can see, that R2 minus 2 pi minus R1 minus pi. Isn't it? If we can write like this, we feel that here R2 minus 2 pi is the gap of, the horizontal gap of the second solution. By the way, this point C here is indicating the solution R2, means the x coordinate of this point C, when the graph tan x and x are intersecting each other, this R2 will be the x coordinate of the point C. So let me write it fully. So this is, C is nothing but the R2 comma tan R2, and here B is R1 comma tan R1. Now if you see that R2 minus 2 pi, what does it mean? Suppose you drop a perpendicular from C on the x-axis, somewhere here will be our R2, correct? So let me drop it first. So this is our R2 here, and this gap is indicating the R2 minus 2 pi. Which gap? From here to here. This gap is the R2 minus 2 pi. In the same way, if I drop a perpendicular from this point B to the x-axis, this point will be the R1, and so I have now this gap is indicating the R1 minus pi. So basically it is true for all such solutions, means for n is equal to 2 also, if you feel, it will come as R3 minus 3 pi minus R2 minus 2 pi. So if you just follow this pattern, can we write generally as, here I can write that the Rn plus 1 minus n plus 1 pi is the first term, and minus Rn minus n pi the second term. So let us call this thing some quantity. What do you want to call it? Let me just give you the idea. This gap, I'm saying that gap 1, and this gap I'm saying that gap 2. Means the gap 1 indicates the first root, the horizontal distance between the first root and the previous first pi. The gap 2 indicates the second root minus 2 pi. The gap 3 will indicate the third root minus 3 pi. So the gap n will indicate the nth root minus n pi. So this I'm calling it gn. So automatically this will give you the gn plus 1 because this is the nth gap. And now the expression what we are looking for, we have to prove for this. This is actually what? The Rn plus 1 minus Rn minus pi. It means the expression what we have to prove for some inequality, that is nothing but the gn plus 1 minus gn is this Rn plus 1 minus Rn minus pi. It means let's call this gn plus 1 minus gn as delta g. Means the difference between the gaps. It is actually the gaps of the gaps, maybe we can say. Or this is not the continuous gap, you can say, but this we can understand as a difference between the two consecutive gaps. So difference between the two consecutive gaps is our choice of expression or the expression concerned, and that I have to prove for something. So what we have to prove now? To prove is delta g is lying between 0 and 1 over n into n plus 1 pi. So this thing we have to prove. Sorry, n square. That's correct because I can take n common. Yes. So this is what I have to prove this thing. So first of all, we try to prove this delta g greater than 0. And how do we prove it? So for that, I'm going to again observe this graph carefully. So let me just copy this graph. So observation number 1, you can see that first. I'm calling observation 1. You can see carefully that every root is actually lying between the n pi, means that if I'm saying that R1 is lying between pi and this is 3 pi by 2, the next asymptote. R2 is lying between 2 pi and 5 pi by 2, that is the next asymptote for the tangent graph or the tanx graph. It means I can say that the n pi is lesser than Rn, but Rn is always lesser than the next 2n plus 1 pi by 2. So if you see that the Rn plus 1, if you want to write, it is lying between n plus 1 pi to 2n plus 3 pi by 2. Okay. The second observation, you can see that for whatever root you take the gap, that gap never goes beyond pi by 2. I mean to say that you can see that the gap n is always lying between 0 and pi by 2. How I'm saying that? Let's see. This is gap, I'm saying the distance between the root and the pi, means the previous pi. But you can see that every root is not falling beyond this vertical asymptote pi by 2 or the odd multiple of pi by 2. So it means that the distance between this n pi and the next asymptote is always pi by 2. And the root is falling just behind pi by 2. So gap will never pass pi by 2. And so the gap will always lying between 0 and pi by 2. We can say carefully. Correct? And also the gn plus 1 is lying between 0 and pi by 2 also. It doesn't matter which root you are taking, but since I have to take the difference of these gaps, that's why I'm taking gn and gn plus 1 always. The third observation is obvious actually, that the tan x is equal to x will give you that if I say tan Rn, it means it's just Rn, because Rn is the root of this equation or the solution of tan x is equal to x. Now from these observations we are going to establish our proof. So you can see that from the observation number 2 only I have proved already the left inequality. Means you can see that gn plus 1 minus gn is our delta g. And remember what we have to prove? Delta g lying between 0 and 1 by n square plus n pi. So you can see that the gn plus 1 always lies between 0 and pi by 2. And gn is always lying between 0 and pi by 2. So the gap gn plus 1 minus gn, the difference, will also lying between 0 and pi by 2. So I can say safely from observation 2 the delta g is lying between 0 and pi by 2. So the left inequality, I can safely say that the delta g is greater than 0. So that is the first inequality we have proved, the left one. The second inequality is a little bit interesting. Means you already proved that a delta g lying between 0 and pi by 2. It means what we have to establish on the right hand side, this is also less than pi by 2. Correct? Because if it will surpass the pi by 2, of course this inequality will never hold. This delta g less than pi by 2. But we don't care about the pi by 2. We have to establish this thing only. This part already proved. So for that, what we can see that now from this first, I can now observe, not observe, is just established relation, that from first I notice that the delta g lying between 0 and pi by 2, and for every angle which is in the first quadrant, the tan of that angle is higher than the angle. How can you say the higher than the angle? You can see the graph also. This is our first quadrant from here to here. From here, from A to this is the first quadrant, because this is pi by 2 you have. You can see the tan graph is always greater than this. Correct? So in this way we can say that tan, but you can see that from pi by 2 to this point, you can say that this x graph is higher than tan x. So it is for the first quadrant, I can say safely that if the angle is in the first quadrant, the tan of the angle is higher than the angle. And so I can write that delta g is lesser than tan of delta g. So how it came to think like that? Because we have to establish the right inequality. So I must have something more than delta g. And we observed the graph and we got that idea that tan of delta g is there. Now I'm going to write the delta g in its original expression. So delta g is nothing but, so I'm here writing an equal sign for this tan of delta g. I can write tan of delta g is nothing but the gn plus 1 minus gn. What is gn plus 1? We have actually written first. This was gn plus 1 was here, the rn plus 1 minus n plus 1 pi, or gn plus 1 minus gn. We can write directly this thing. So let us write it. Gn plus 1 minus gn is just rn plus 1 minus rn and minus n pi, minus pi. Correct? Now this is a little bit tricky here. What is the trick? You can think this quantity as the minus 1 pi, and you are adding this minus 1 pi to rn plus 1 minus rn. So this will always give you the structure of tan of minus pi plus theta or plus something. So let's assume this quantity is theta. So I can think it as minus pi plus theta. And this is nothing but the tan of minus pi plus theta is the n pi plus theta. It doesn't matter what is n, is a negative or positive. It will always give you the tan theta. So I can write this thing as tan of Rn plus 1 minus Rn. And now we can apply the formula tan A minus B here. That is tan of Rn plus 1 minus tan of Rn divided by, let me write it, divided by 1 plus tan of Rn plus 1 into tan of Rn. But you notice from one observation, the last one, tan of Rn is Rn because it's the solution, or you can also write directly. What is that? Rn plus 1 minus Rn divided by 1 plus Rn plus 1, Rn plus 1 into Rn. Now, we have this thing all done for the right hand side of this inequality. If you understand this thing, this we did for this quantity. Means this quantity I can replace at the place of tan of delta g in this inequality. So I'm going to write now delta g is lesser than Rn plus 1 minus Rn divided by 1 plus Rn plus 1 into Rn. Alright, this is our inequality established, and from there we have to think something. So how do we think? Again, we go to our all observations and see what is happening. You can feel that, not feel means you know this fact, Rn plus 1 minus Rn, what I can write? Because you see the Rn plus 1 minus Rn plus 1 minus Rn minus pi is delta g. So can I write the Rn plus 1 minus Rn is delta g plus pi? So I'm writing here delta g plus pi. Alright. Now I have to deal with this situation, the Rn plus 1 into Rn. So from here that should be pi actually. So that should be pi, and after that we have to establish some relation of Rn plus 1 and Rn. So what we do? Let's observe this thing. From here we can see the Rn is greater than n pi and Rn plus 1 is also greater than n plus 1 pi. So we multiply them, what we get together, that the Rn into Rn plus 1 is greater than n pi into n plus 1 pi. It means I can write, so I'm just writing this since I have this thing. I'm writing this thing, Rn into Rn plus 1 is greater than n into n plus 1 pi square. But I need the 1 added to this expression in the denominator and also multiplied by delta g plus pi on the top. So it will not give you any change in the inequality if I add 1. So that will give you 1 plus Rn into Rn plus 1, and here 1 plus n into n plus 1 pi square. And when I reciprocal and multiply delta g plus pi, the sign of the inequality will get reversed, and so I'm getting what? 1 by 1 plus Rn into Rn plus 1 into, is lesser than 1 by 1 plus n into n plus 1 pi square. And if I multiply this delta g plus pi on the top, it will not change the inequality sign, so I can safely write this thing as our established one inequality for n and n pi, n plus 1 pi. Alright, now you observe this thing, the second inequality is here, the first inequality is here. So from the first and second, what we observe, that like x is lesser than y and the y is lesser than z. So can we not say that x is lesser than z? So we can write from first and second. So from first and second, what we can write is delta G is lesser than delta G plus pi. Why I'm writing pi always like this? So delta G plus pi divided by 1 plus n into n plus 1 pi squared. Now we have to simplify this thing and get that delta G one side so that we can say that what is happening for delta G in terms of inequality. So just multiply this thing. So what we get here is delta G plus delta G times this whole quantity n into n plus 1 pi squared. And on the right hand side of the inequality, we are left with only delta G plus pi. Now we can see that delta G and delta G will get cancelled. And since I have to write the expression for delta G in terms of inequality, I'm sending this whole quantity on the right hand side in denominator. So you can see what will happen after this. There's a pi divided by n into n plus 1 pi squared, and this 1 pi will get cancelled again, and we got that delta G is 1 by n squared plus n pi, and that's the right hand side of the inequality we had to establish. So we can say now that we proved is 0 is lesser than delta G is lesser than 1 by n squared plus n times pi, and that's the proof. Okay, so there is another way also to think. Can we think from the calculus point of view? So that I'm giving only the idea. So how do we establish this whole inequality with the help of calculus? So you have Rn plus 1 minus Rn minus pi is 1 over, means lesser than 1 over n into n plus 1 pi and more than 0. So if we have to establish this thing, and I have the support of this tan x is equal to x, and we have to establish this thing, it means equivalently we can say that I want to find Rn, which is Rn more than Rn plus pi but lesser than Rn plus pi plus 1 by n into n plus 1 pi. So if we can establish this thing also, it is actually equivalent to the original expression what we have to prove. So by any chance, can we prove that the Rn plus 1 lies between Rn plus pi plus and Rn plus pi plus this quantity? What does it mean? You notice one thing. So you can get idea, even if you don't solve this question completely, you get completely a very interesting idea. So let's think. This Rn plus 1 is the root of or the solution of tan x is equal to x. It means now I have to establish this thing to prove that Rn plus 1, the root, lies between these two quantities, the ends, I mean this and this. If Rn plus 1, any root is lying between two given quantities, what is the meaning of this thing? It means that suppose I assume that the fx as a function tan x minus x, and you are saying that it has a root Rn plus 1. It lies between n plus 1, Rn plus pi and Rn plus 1, Rn plus pi plus this quantity. So first of all, we check from the calculus that the f dash x is tan x, sec square x minus 1, that is tan square x, is always positive. It means the graph of function is always increasing. So fx is always increasing. So if the graph is always increasing, there must be one root if it crosses the x-axis one time. And what is the phenomena we have to establish, or we have to what kind of condition we have to establish in support of our argument the graph is crossing the x-axis at one time? and Rn plus 1 is the root. You know that the Rn plus 1 is lying between these two quantity we have to establish. It means tan x, this is a graph I'm drawing just schematically to give you the idea. To tan x minus x is, let's say this is the graph like this is going. And if this is Rn plus 1, and you know that the Rn plus 1 is lying between Rn and this one giant quantity, at Rn plus pi, the value of the function should be negative. And at this Rn plus pi, Rn plus pi plus 1 by n into n plus 1 pi, the value of the function should be positive. So let's find it. So you get it here, f of Rn plus pi is what? Tan of Rn plus pi and minus Rn plus pi. Correct? And so tan of pi plus theta is tan theta. This is tan of Rn. And minus Rn, here the plus is there, Rn and plus pi. You can notice the tan of Rn is Rn. So Rn minus pi, and you got that this value is negative. Now the second thing is, if we establish that the f of Rn plus pi plus 1 by n into n plus 1 pi is a positive quantity, then I'm sure that the Rn plus 1 is a solution, and that is the solution lying between this Rn plus pi and Rn plus pi plus this thing. So this part I can it's a very long calculation, but this part you can establish, and this is the one other way to think this question. Alright, see you in the next video with some other good question. Till then, stay math active.